Section 5.1, Polynomial Functions and Models. In this section, and actually the entire chapter 5, we are going to be talking about polynomials. Okay, now I know you heard me use this word polynomial before this semester. Okay, we actually talked about it back in section 3.1 for the first time when we were talking about domain, and we were learning how to find the domain of a function from its formula or from its equation. And I told you that the domain of a polynomial is all real numbers. And that was because any polynomial that you were given, it does not contain any square roots and it does not contain any fractions. And those were the two troublesome spots for domain. Okay, those were the things that got you in trouble. And since a polynomial is devoid of square roots and fractions, you could plug in anything you wanted for x, and so the domain ended up being all real numbers. So we do know something about polynomials from earlier in the semester. Okay, we have never formalized the definition of a polynomial, so we're going to do that now. We're going to talk specifically about what a polynomial is. In this section 5.1, we're going to not only concentrate on what a polynomial is, but we're also going to look at the graphs of polynomials. Okay, so that is what we're going to do. And then we'll do some other things related to polynomials in 5.2 and 5.3. Okay. All right, first thing in the notes, this first bullet point kind of tells you the definition, the mathematical definition of a polynomial. If you open your textbook or any math textbook really, or Google what is a polynomial, you're probably going to see some definition that looks like this box. It says a polynomial function in the variable x is a function of this form. And when you look at this, this is very, very mathematical. So you may wonder, okay, well, what exactly does this mean? Okay, if you read down here, it tells you the little a's that you see a bunch of a's. They are constant, so they are just numbers. And then what you see a bunch of powers of x, like this is x to the nth power, x to the n minus 1 power, and then down here you have x to the first power, and then this term doesn't have an x. So yes, this is kind of intimidating to look at. But what I have, there's some more vocabulary words down here. But if you skip down a little bit in the notes, okay, what I'm going to do is try to translate for you what that box says, how we can think of a polynomial in everyday language. Okay, you go back up here, like I said, the a's represent just numbers. And then you've got all these powers of x. And if you notice, you see some plus signs. So really, all a polynomial is you're adding or subtracting. You can have subtraction. You're adding or subtracting powers of x, okay? So that is how you can think of a polynomial in everyday language, okay? You are adding or subtracting powers of x, okay? So things like x squared or x cubed or x to the 5th, x to the 10th, things like that. Okay, I need to get a little more specific. Okay, like I said, there's vocabulary words up here, but I will come back and explain those to you in a minute. Let's keep going along the lines of how we can think of a polynomial. Okay, it's a little more complicated than just adding or subtracting powers of x. There are some things that you're not going to see in a polynomial. Okay, so I guess let me go ahead and start off with an example of something that is a polynomial. Like I said, it's a function for sure. It's a function. If we have f of x is equal to, oops, let me change this. Let me make this 4x plus x cubed. Okay, that is a polynomial. Okay, you're adding or subtracting powers of x. Okay, hang on, let me rewrite this, guys, so that when you go back through your notes, you can realize that this is a 4. Okay, so we are adding or subtracting powers of x, okay? This piece has x to the first power, this piece has x to the third power. We're adding or subtracting powers of x. So this guy is a polynomial, okay? So like I said, it's very important to notice, okay, There are things that you're not going to see in a polynomial, okay? And we need to understand that before we can truly digest the definition of a polynomial, okay? So things you're not going to see, you're going to be adding or subtracting powers of x, but things that you're not going to see, okay? You're not going to see negative powers of x, okay? And remember, your variable may not be x. It could be some other variable, but generally we talk about x, okay? So you're not going to see negative powers of x, okay? So for example, if I had, let's see, let me make something up here. If I had 5x to the negative 1 plus 2x to the 3 halves, okay? This would not be a polynomial, okay? So I'm going to say this is not a polynomial, okay? Because what you see here, okay, this piece right here, x is raised to a negative power. That's bad, bad, bad. You won't see that in a polynomial, okay? Something else you won't see in a polynomial is you won't see fractional powers of x. Oops. Fractional powers of x. So this guy I just wrote down, okay, see this other piece, okay, it has x raised to a fractional power. So besides the fact that this has a negative power, okay, if you just had this part, this would also not be a polynomial because it has a fractional exponent, okay? So this kind of serves as an example for both of these no-nos, okay? All right, so something else you are not going to see, okay? You are not going to see any square roots, okay? And we talked about that like when we said domain. When we did domain, we said you couldn't have a square root because, you know, that would prevent it from being a polynomial. So you can't have any square roots, okay? But you also can't have any cubed roots or fourth roots or fifth roots and so on. So I'm going to put this and then I'll put etc. Okay, you can't have any kind of roots. Remember, roots are also called radicals. You cannot have those at all. Okay, so if I gave you 7x to the fourth minus the square root of x plus 1, okay, that is not a polynomial because it contains the square root. Okay, so this is not a polynomial. Okay, all right. Something else you can't have. There's a lot of things you can't have. Something else you cannot have. You cannot have a fraction with x in the denominator. Okay, so for example, I'll put it right here because I'm running out of room. If I gave you 1 minus 1 over x, okay? This is not a polynomial because it contains a fraction and that fraction has an x in the denominator, okay? So this is not a polynomial. And then the last thing that you won't see for our purposes, you can't have absolute value, okay? So there's going to be no absolute value. Okay, so we've talked about the absolute value function before when we did transformations. Absolute value function or anything that contains it is not a polynomial. Okay, so for example, absolute value of x plus 10. Okay, this is a function, but it's not a polynomial function. Okay, so this is not a polynomial. Okay, all right, so just to summarize, okay, what is a polynomial? Okay, well, you're adding or subtracting powers of x or whatever variable you're using. But you're not going to see these things. You're not going to see negative powers of x. You're not going to see fractional powers of x. You're not going to see square roots, cubed roots, fourth roots, fifth roots, any kind of root or radical. Okay, you're not going to see fractions with x in the denominator. And you're not going to see any signs of absolute value. Okay, so if you see any of these guys, automatically not a polynomial. Okay, all right. So back to up here. So now we have a kind of an idea of what a polynomial is. There's a whole lot of terminology that is associated with polynomials. Okay, so if you look up here and you see the words that are in bold, okay, we need to talk about what the word degree means. Okay, we need to talk about coefficients. Specifically, there's something called the leading coefficient. Okay, we can talk about the terms of a polynomial. There's a constant term, a leading term, standard form. Okay, so there's lots and lots and lots of terminology that goes along with polynomials. Okay, so instead of kind of reading through these definitions, I think we're going to jump straight into example 1, where I give you a bunch of polynomials, and for each polynomial we are going to talk about these vocabulary words for each polynomial. Okay, so let's go ahead and start on that.